Welcome to Junior Dev Interview Crash Course. In this episode, we are going to break down one of the most fundamental high-frequency back-end interview questions, MySQL InnoDB ACID compliance. By the end of this video, you won't just memorize definitions, you will understand the core logic so you can answer any variant ACID interview question confidently, even if you know a little bit more than your competitors. You would get a greater chance of getting the job. For most junior developers, ACID is a double-edged sword. Everyone can recite the 4 letters, but most candidates get stuck in interviews. The reason is simple. You only memorize surface definitions, but you don't understand what problem each property solves and how InnoDB implements it at the bottom. Today, I will teach you a universal fixed answering framework. Once you master this logic, no matter how the interviewer changes the question, you can give a professional high-score answer. First, let's start with the standard interview opening definition. ACID stands for atomicity, consistency, isolation, and durability. These are the 4 core transaction properties of relational databases, serving as the fundamental standard for reliable data transactions. Among all MySQL storage engines, only InnoDB fully supports ACID compliance, relying on undo log, redo log, lock mechanism, and MVCC to guarantee transaction safety in high concurrency scenarios. Now let's break down each property one by one with plain explanations, business causes, and underlying implementations. First property, atomicity, also known as the all or nothing rule, prevents data inconsistency caused by half-executed transactions. In plain words, a database transaction is an indivisible minimal work unit. It either executes completely successfully or fails completely with no partial data left. The high-score interview standard answer is atomicity ensures all operations within a transaction are indivisible. If any step fails or the system crashes, all modifications will be fully rolled back to avoid half-executed transactions. The classic business example is a bank transfer. Deducting money from account A and adding money to account B is one transaction. Atomicity prevents the bug where A's balance is deducted but B receives no money. InnoDB implements atomicity through undo log. It records the original date snapshot before modification and supports complete rollback when the transaction fails. The second property, consistency, the core guarantee of data legitimacy and business integrity. Plain explanation is before and after transaction execution. The database must always stay in a legal valid state without breaking any rules. Formal interview definition is consistency ensures the database transitions only from one valid state to another. All database constraints and business rules remain intact, with no illegal dirty data generated. Here is a key interview headline to distinguish it from atomicity. Atomicity guarantees the transaction process is complete, while consistency guarantees the final data result is correct. InnoDB achieves data consistency through dual protection. Built-in database constraints plus transaction mechanisms of undo log, redo log, and isolation logs. Third property, isolation, which solves concurrent transaction conflicts. Plain understanding, when multiple transactions run at the same time, they are mutually independent and isolated. Uncommitted data from one transaction will not interfere with others. Standard interview answer: transaction isolation ensures concurrent transactions do not affect each other's execution results. Different isolation levels balance data security and system performance. It solves three classic database concurrency problems: dirty read, non-repeatable read, and font read. InnoDB implements isolation perfectly with MVCC multi-version concurrency control, row-level locks, and gap locks, realizing non-blocking reads and safe concurrent writes. The fourth property, durability, the permanent guarantee of committed data and avoid data loss caused by abnormal downtime. Plain understanding. Once a transaction is successfully committed, the data changes are permanent, even if the server crashes or restarts immediately. Committed data will never be lost. Durability ensures all committed transaction modifications are persistently stored on disk. System crashes, power outages, or restarts cannot cause committed data loss. InnoDB's core implementation relies on redo log. During transaction commit, redo log is sequentially flashed to disk. After a crash, InnoDB replies the redo log to recover all committed data, achieving absolute durability. Let's make a concise recap to solidify your interview memory. Atomicity relies on undo log, ensuring all or nothing transaction execution. Consistency is a core goal, ensuring all data is legal and valid. Isolation relies on MVCC and logs, ensuring concurrent transaction safety. Durability relies on redo log, ensuring permanent data persistence. These four properties work together, making InnoDB the only fully ACID-compliant MySQL storage engine for reliable high concurrency business data processing. Finally, here is the pro interview skill to help you stand out from other junior candidates. Don't just only recite definitions. A high score answer must follow this fixed framework: plain definition, problem solved, plus business case, plus underlining InnoDB implementation. With this logic, you can handle all ACID variant questions, no matter how the interviewer adjusts the question form. Thanks for watching. I hope you found this helpful. Don't forget to hit subscribe and the bell to stay updated on more videos. Got questions or topic in mind? Drop a comment. I would love to hear from you. See you next time.